So what's interesting is this is about a foot. I'm about 10 inches for my shoe. This fast-moving water, if we had fast-running water, can actually float a regular car. So just like a regular four-door sedan. Two of these, so 2 feet of water, thankfully I have two. So that right there, if you had this amount of fast-running water, what's going to happen is that can actually float an SUV. That's not very much. I mean, look at this right here.
No, it really isn't.
But the key is it's got to be fast-moving.
Right.
But that is astounding.
What do we call fast-moving? What's
just fast-moving water? It would just be rushing water, running water. But see, that's the thing, and that's what's scary is when you come up on water and flooding, you don't know how fast it's moving, and number two, you don't know how deep it is, and that's what's dangerous. And listen, we get flooding around here. I remember covering 2011, the remnants of a tropical storm. We got 7, 8, 10 inches real quickly in Lancaster County, caused big-time flooding, and then Susquehanna River flooding. Don't forget about Agnes, 72, all the flooding there. You have two types of flooding. You have river flooding, and you have local flooding from the streams and creeks. The river flooding, like the Susquehanna, you have a heads up. And you know why? Because it takes some time. It takes a couple days from all the water in the streams and creeks to enter and empty into the Susquehanna. I remember being in Marietta in 2011. I was working for Channel 8 at the time. And in just a few hours, it's expected that Front Street will begin to flood. And here's the reason why. Take a look at this storm drain. You'll see how high the water already is. In fact, you even hear the water filling in that storm drain. I literally watched Marietta get flooded. And here's why. There are storm drains. They empty right into the Susquehanna River right there. So there's pretty much no barrier between the river and the town. So what happened is, as the river started going up, literally the water came up through the storm drains. And over the matter of about 5 hours, I watched from no water in Marietta, I watched literally the water come out and go easily about 4 feet, flooding the town. It was unbelievable. The next day, I see up in Cumberland County along the Susquehanna River, New Cumberland, there was a giant green dumpster, one of those rectangular ones, and this thing was bobbing like a buoy, like a piece of driftwood, just kind of going like this. And the water, it was probably only about 2 feet. From my firsthand experience, to see the power of water, and we really don't think that it has that kind of power, I'll never get out of my head.
Yeah, I bet you won't. We do see changes in the weather. And as the temperatures rise, some areas will get rain while others will get drought.
Isn't that crazy?
Yeah.
So as these temperatures go up, because we've been seeing a big rise in temperatures, it's going to cause droughts because the warmer it is, the quicker to get some of that moisture out of the ground. So where it's really warm, you're going to have drought happen more often. What's really interesting is if you look at a map of the United States, I forget the parallel, but there's a line that goes right through the United States, and that's the area that basically says, hey, on one side, there's enough rain coming out of the sky, you don't have to water your crops. On the other side, yeah, you got to water your crops, and it's right through the plain states. As time goes on, as we warm up more, that line is shifting more and more toward us, meaning more places in the plains have to actually water their crops because they're getting less rain. That's one thing that warmer weather does. But at the same time, warmer weather not only causing droughts, causing flooding, right? So come on, how are we doing two different things? Well, here's the reason why. So when it's hot, and we know this here in Lancaster County, it's usually pretty humid. It's pretty humid most of our summer.
Sure is.
Not a fan of that, but you know what? That's why I love a 4-season state. It's so great in PA.
It is good.
So the warmer the air is, the more humid it could get. And you know what you're feeling when you're feeling that humidity? You're feeling the moisture in the air. You're actually feeling the gas form of water. So the warmer it gets, the more humid it gets, which means the more water that is in the air, which means when we get storms, the more water can come out of those storms. That's also happening with hurricanes. So not only because of our warmer weather, the warmer air, are you actually getting now more rain out of these hurricanes, but hurricanes themselves are getting stronger. They're getting bigger, and they're also getting wider. And here's the reason why. As our air warms up, it warms up the ocean. But as our ocean waters warm up, it makes hurricanes stronger because that's the fuel for a hurricane. You want a big hurricane? Just get it warmer ocean water. So not only is the ocean water warmer to make these bigger and stronger, but the spots where the ocean water stays warm is farther north. When I've tracked hurricanes here for Channel 43 and Channel 8, usually about the Outer Banks is where they'll die. See, they need 80-degree ocean water. Well, now we're starting to see that 80-degree water line come more north. And that's important to us for when we get these coastal hurricanes that hug the East Coast, because once a hurricane hits water less than 80, it starts dying out. It weakens like that. If you have this warmer water farther north, that means we have the potential to not only get more hurricanes, but also get hurricanes that are stronger than what we're used to seeing that cause this type of damage with flooding, like, say, Agnes and the remnants of other storms like Lee.
Wow, boy, there's so much to think about when we're talking about weather. But we're going to take a brief pause and check out this weather clip.
This is wind damage from Hurricane Michael. The puppy came on shore down that road, and these trees, there, you see how they have a little bit of a triangle shape there? And over here, they were snapped this way as the winds blew out towards sea. The reason the winds were going out toward the sea, that's the Gulf of Mexico, is because the center of the storm came right in there. So let's think about how a hurricane moves. The winds go counterclockwise, like this. If the center of your screen is the center of the storm, we're on this side of the storm where the winds are coming out to sea. And as those winds blew, they snapped all these trees. So much damage left around. It's about 6 months later after the storm, and look at those snapped trees.
Ah, the weather. Welcome back to Behind the Lines with Drew Anderson, our meteorologist here. Tell me about hail.
Isn't that cool?
Yeah, it's, well, when it's not damaging.
I have some dents in my car from a big storm that went through Berks County, rolled into Lancaster County. I remember even a couple of years ago we had a big hailstorm in E-Town, and it's debilitating for corn. I mean, it just wipes out corn crops.
Right.
Hail is is just a nightmare for farmers.
Tell me what hail really is.
Yeah. So here's what happens. A little raindrop gets pulled up, way up in the sky. It freezes, comes down. But it doesn't fall because that warmer air, that fuel for the storm, pulls it right back up again. And it's like a cotton candy machine in a thunderstorm. Go with me on this one. So a cotton candy machine, right? You go to the fair, you go around and around and around. Your cotton candy gets bigger and bigger and bigger. Same thing happens in a thunderstorm. That little raindrop that became a piece of ice, it goes around and around and around. Every time it goes up, it freezes. On the way down, it starts warming up. It runs into more raindrops. It gets bigger. Comes up again, freezes all again, runs into more raindrops. It gets bigger. Now you have this big piece of ice. It gets bigger and bigger and bigger. What's interesting is these thunderstorms are about 8 miles high. So when we get hailstones, they've been falling through the air sometimes around here for 7 miles. Think about that.
Wow.
7 miles. It's usually pretty warm in the summer. So it's melting that hailstone as it falls. Hail, believe it or not, is spiky. It would look like this, a big ball of ice in the center and little spikes. We don't see that around here because those little spikes have melted because that warmer air has melted them. So why do they fall out of pretty much the cloud? Why does the cotton candy stop? Well, it's because that warm air that's feeding the storm, making that thunder cloud just get bigger, it can't hold up that piece of ice anymore. And when that wind feeding the storm can't hold it up, down it comes, it melts on the way down, and boom, we get some hail.
I'm never going to look at hail the same again.
You'll think cotton candy from now on.
Absolutely. So, last question. Lightning.
Yeah, lightning's interesting. You've, I'm sure, experienced static electricity. I get that all the time in the winter when it's dry. I think of lightning like this. If you get a balloon and you rub a balloon to your hair, and I got enough product in here, my hair shouldn't get too messed up. But if I had something that's plastic, is your board plastic by chance? May I borrow this?
Absolutely.
So I'll wash it afterward, don't worry. But if you get plastic, it should make my hair stick up because plastic...
Oh, I hope it does.
It does, yeah. Plastic is
that's
attracted
good. That's really good.
to... Your hair has negative charges. Plastic is a positive charge. It's like a battery. You know how a battery has a plus and minus? Here's the plus, here's the minus.
Okay.
And you get it sticking up. So
Right.
I have some here. I'm going to clean it off.
Oh,
don't
that's
worry.
all right. That's okay.
Right afterwards. So who's rubbing a clipboard up in the cloud? Here's what's happening. Hail. When hail hits other hail, it's the same idea as I was just doing. It creates friction that creates charges. And also as these ice crystals move around the cloud, they do the same thing. At a point, the cloud can't handle all those charges, so they start coming out. When you actually see it with those high-speed cameras, it looks like little, I don't know what you want to call it, just cascades of lightning coming down.
Okay.
And so what we're seeing is we're seeing the charges travel down from the cloud. Well, opposites attract, just like I kind of saw my hair sticking to that clipboard.
Sure.
So then the opposite charge starts coming up from the ground. When they connect, that's that big, gigantic light, and the light actually travels from the ground up, following that path where the charges connect. Pretty cool.
Wow, very
And scary.
cool. You make it interesting.
Well, good.